Is that like you have no idea which one it's actually going to do?
The purpose. This started out with an Oleg thing, but the purpose was to be able to, okay, I'm going to read a configuration file, get something I want to be global in my program. Well, I can give this thing, and then for the rest of the program, I'm going to be able to access that via type level stuff. But
if you give again,
then the world blows up.
Okay. So the next thing I wanted to talk about were nested data structures, because you don't want to end up in a situation where you're working with zippers of zippers of zippers of zippers of zippers, right? That doesn't really work well. Like if I'm working with lists of string, right? If I have A, B, C, D, E, F, right, in a list, and I want to be able to edit at the character level. How can I get to the character level with a zipper? Well, I'd have to take a zipper, get the first string out with the cursor, and then open a zipper on that, right? Or you can use it's called up and down to go to kind of focus and drill deeper into the data structure. And that's what we're working at.
But the first one that you said, would that treat the whole thing as a continuous string, though? Like if you open a zipper...
No, you'd still only get...
Yeah, you'd only get that, right?
Yeah.
So that wouldn't work.
Right.
So
Zipper
that's what you're saying,
zippers.
right? So, yeah.
Right.
Okay, all right.
So this is primarily, the up and down that work this way primarily come from the Lens library. I don't know many other zipper libraries that do the same thing. But I also want to point out that your finger tree talk last time also has the same problem if you wanted to write a zipper for your finger tree.
A zipper for a finger tree is 2 finger trees.
Oh. Never mind.
And you can actually jump around. You don't just you're not restricted to just small movements. You can jump.
Okay. So what up and down give you are zippers that go from this list of A zipper to a zipper on A, right? For the list zipper. And if it's a tree zipper, it'll go from a tree of A's to an A and open a zipper on A.
Wait, both up and down?
No, I made a mistake there.
Okay,
One
all right.
one goes the other way.
Yes, one goes the other way. The arrow should be reversed.
Wait,
on the
what's a zipper of A?
So assuming A has some traversal on it, you open a zipper on A. It's a zipper with elements of A.
What, is this a zipper of lists?
Oh, okay.
I'm using list as an example here just to keep it.
So that's
I mean,
that's the type of
what
focus.
the inner zipper?
Wait.
Sorry.
In this case, for
The
this
element
example.
type here is A, and that's what you get out when you focus.
So you're saying this is for some nested data structure, but you haven't told me which. But
You're talking an example of a character
We just
arrays.
don't. It looks like we don't have the container.
What?
Is
The
the zip-
container type is not evident in this slide.
Yes, it is. It's a list. I was using this as an example here.
So the zipper, it's all lists, right? And so that's because it's a list and list.
Yeah.
That they're both the same type of structure.
Okay.
They're
Yes.
both lists. So they're both lists, and so that's how here you have they're both zippers, even when you go up or down.
No. That's wrong. The slide's wrong. This should.
Right. But they're
This
both
is the type of down, not up.
and up is the flipped.
Yeah.
But the thing is, they're both zipper. They're not like zipper and then row zipper or something like that. Because
Yeah.
it's list of A's.
Yeah.
Okay.
Yes.
Okay.
Yes. Although if it was generic zippers, then we also have to track the container type in the type. Down is actually really easy to implement. It's just zipper. You get the focus out and open a zipper on the focus, and you avoid the nested zipper type issue where it expands. But you still only get a zipper on each element one at a time.
But so how does up work?
Up is much more complicated to implement because you have to start tracking parents and
So then this is a different zipper type than what we had
yes,
before.
you need a
physically.
different zipper type now.
Okay.
So, but when you said you were opening up, when you open up each one and you're dealing with them individually, then do you have continuity from CD?
No, you don't.
Okay. Oh, okay.
Yeah, you still don't get the continuity from
Okay.
CD.
All right. I thought you would have solved that.
Oh no! I was just solving the zipper.
Right.
zipper
I got you.
problem.
Okay.
Which sort of suggests that maybe you don't want to represent it like that.
What if you're working on a document where it's represented as lines? Right? You have lines in the document, and that's how you're tracking it. And so the user clicks, and you need to get to that position in that line.
Yeah. You definitely. I mean,
I'm not saying it's a good idea to represent it that way.
But-
I'm saying that
no,
would be
but-
a.
but
simplistic level
it
where you can't show you the
actually,
stuff that-
I mean, I don't know
You
if
can
that
have.
is or isn't, but that kind of thing, I'm sure, can actually be important because I'm not sure. I imagine because otherwise getting to the right line could take you a very, very long time.
Yes. Yes. Any thoughts?
Well, I mean, aside from the fact that it may be fast enough anyway if it's text, but
Yeah.
but if it's, I mean, I don't know. I mean, I don't know what. I imagine that there could be applications where you're not dealing with text, where that's more important. Like, I mean, if you're in a word processor, when are you actually going to want to jump to the exit line? It doesn't happen. So,
When the user clicks, right?
well, right, but you're on one page.
Right.
And so even if it's a very, very slow way of getting there, it's still going to be fast.
Yeah. Because it happens on a macro scale, right? It's happening once every.
What I mean is that you've got a couple thousand characters, and that's nothing.
Right.
So the more important, but I mean, if you need to be able
That's
to,
what you think.
if you need to be able to jump much bigger, Then you
Zippers
have-
are generally not going to be used in that kind of a context where you have terabytes of data or something, right?
Mm.
Because there you're not going to be interactively walking through the data. You're going to be doing something.
okay,
to the
so
whole
so
data
so
set.
don't represent it as lines, and
Yeah, do
don't
something smart.
represent it as words, and
I had an Ubuntu error once where it downloaded. It's some large file, like in hundreds of gigabytes. Like clearly not a text file, but it decides that it should be opening it with gedit. It's a text editor, which is can be a stress on the computer.
Because gedit loads the whole file into RAM at once. Anyway.
Hopefully you had hundreds of gigabytes of RAM.
The other useful thing is when you start talking about trying to remember the paths to the data structure. I'm going to leave up and down off of this section and the next section because that just starts getting more and more complicated as you tack all these things on. But I think Learn You a Haskell has a chapter and it covers this part in pretty good depth. But you track your breadcrumbs as directions that you're moving through, so left or right. Your zipper, your base zipper type is this pair of lists for list zipper, right? And so we look at the zipper as a pair between the breadcrumbs that we've followed so far, along with the state of the zipper currently. So we can update. Oh, this doesn't.
So
look
you
as
always add on to your breadcrumbs, or do you delete it if you went back? Like if I go right
good. Yeah.
and
So
then left.
insert and delete would have to.
No, I'm saying if I went right and then left, what happens to my breadcrumb? Is it empty or does it say?
No, it's going to say
left?
right then left.
Okay.
Yeah. It's preserving the history of what happened, not. And this kind of breadcrumb doesn't track inserts and deletes. You need a bigger type to track.
Yeah, so you're just saying,
Insert.
you're just tracking where you went.
Yeah. So, go left and go right are both manipulations of the zipper, and we can we can write out the code for them. Oh, come on, go back. Wow. Okay, there we go. I wrote out the code for them. I didn't realize it was going to look this awful. But the idea is that for left, we unpack the inner, what's it called? The inner zipper type, right? And we do the normal go left thing. So if you look at this and look at it over here, it's just doing the same thing we did for go left before. The only addition is that it's tacking on a left onto the crumbs. And same thing for right. It's doing the same thing it did for go right that we wrote before, except now it's tacking on the right onto the crumbs.
Oh, so your edit. This is not just an edit history. This is a history of all the motions.
Yeah. It's the motion through the structure. So now, if you need to save and come back, like you say, like the user made a series of edits, they opened a bunch of web pages, right? And they have a history of browsing that you want to save. And they close the program and then reopen it, and they want their history back. You got your history back. You can get back to where they were while still maintaining the forward and backward part.
Yeah, makes sense.
So we can update get focus in the same way. That was pretty straightforward. And then we can do a replay where we just fold this action function over the zipper of the list to open a zipper at the same location where we were at before, which is just go left, go right until we get to where we're supposed to be, based on what we see in the thing. If there were more things we'd have to do, like inserts and deletes, we wanted to track as well, so we were tracking full edits and not just the path, then we would have, action of insert A or something, and then we could do that as well.
You could just make your breadcrumb a list of zipper A to zipper A instead of
What?
you could make instead of your breadcrumb being a list of left or right.
Yeah.
You could just make it a list of zipper A to zipper A.
Yeah, because saving those is really hard.
Yeah, how are you going to write a function to disk?
What? Why are you
Zipper-
writing a function of this?
Zipper A to zipper A?
Yeah.
That's a function, right?
Yeah.
How are you going to write that to disk?
Okay. If the thing is to write it to disk. Okay.
It's not just writing the disk, right? You want some simple representation of it. Not
It's the simple representation.
It's the simplest I can think of.
for a programmer.
But it's not good for.
I'm just thinking because then when you add insert and delete, you don't have to change your breadcrumb. It's just the same thing.
No, they're not zipper A to zip. Oh, I guess they are.
I'm saying
once
instead of L,
yeah.
you just literally put in go left, and instead of R, you just literally
Right,
put in
right,
go
right.
Well, the thing is, as soon as you
And
don't,
insert would be insert A, not.
Yeah.
but as soon as you don't care about sending things to disk, you can forget about those functions and just use sharing and just have all of the zippers. You don't need the functions between them at all. You just need to have. You just use.
Oh, you can just track the zippers
Yeah.
because you're only going to play it from the start. You're only going to play it from the initial.
What if you don't want to
No,
play
no,
from the start? What if you have a series of edits that you
Okay.
then play on something else?
Well, then I guess you keep track of the
I
functions.
see. Oh, okay,
Yeah.
I see. So you're playing something else and hope that it works.
Yeah.
Okay. Sounds like
You'd be
patching
surprised
or
how
something.
often that it does just work, right? A lot of the time, if the data you're working on is big enough, then it doesn't matter.
So
You're gonna be working in the middle.
So patching stuff.
What?
You're patching stuff.
Yeah.
Huh. Interesting.
Yeah.
Okay. Wait. How do you find the right place to start replaying? Whatever. Okay, go on. I guess you find
How
it
do you
and
find the right place to start
I guess you find it and then you start. Okay.
Yeah.
Okay, got it. But you have to sort of keep track of enough context to know if you've hit something where it's going to be a problem to replay.
Well, so that's the next thing I'm going to talk about is
Okay.
actually the handling failure part of it,
Ah,
right?
okay.
Because when you go right on the end of the list or you try to focus the empty zipper or something, you end up with just kaboom because we haven't been handling any of those failure cases. So we could do this with maybe, right? We can just start tacking maybe everywhere and get focus is zipper A to maybe A, and go left and go right or zipper A to maybe zipper A, and we can do this for all the functions, and sure, that works. It's also really cumbersome in the interface, and sometimes that's not really what you wanted, right? Because sometimes you just want to hit the, like, if the user hits forward when they're on the most recent page, you just don't want to do anything, right? And so you want some kind of basic clamping action, not. And so we can add a leftward and rightward function that do that. So I just wrote out leftwards, which moves F. So leftwards moves it from the. I was calling them clowns in my head at the time. Moves the first clown over to the Joker's side, which makes it the current focus. And if we don't have anything to pull off, then we just do nothing. And we do the same thing for rightward and upwards and downwards for up and down. You don't seem happy, David.
Not a fan of saturated subtraction.
It's a useful thing in a lot of cases.
Yeah, no,
until you
I
do with nothing anyway.
totally see how it could
When
be
browsers
useful.
do it,
It's
it
just
doesn't
also
crash when
kind
you
of
hit forward.
ill-behaved. And I'm trying to
That's the
imagine
correct
if there's
page.
any way to make something that's not ill-behaved, and I think the answer is no. So I guess as ill-behaved things go, it's pretty decent.
Because you still have to decide what to do with the failure case, right?
Yeah.
And this is one option is ignore
Yeah.
the failure case, and
Yeah.
you're fine.
It's just that whatever you do in the failure case, it breaks the go left then go right is the same
Right.
as doing nothing, and that's
Right.
kind of sad. But
Right.
I don't think there's a way to avoid.
They're not
it.
inverses.
Yeah. So, go on.
So that was the majority of the talk. The other things I was going to say are that the two main places to go that I found really useful to learn about zippers was the Learn You a Haskell page on them, and then Connor McBride's paper for a little bit more of a theoretical overview.
So I know this goes back to like the very first thing you said, but what's the thing with the clowns on the?
Oh, have you not heard that song?
No.
Clowns to the left of me, jokers to the right, and here I am stuck in the middle with you.
No.
Okay, let's play it.
Hold on, then let me
It's a
write this down.
culmination.
Strictly positive.
Who does this song?
DJ.
Better stop the recording or YouTube's gonna catch it.
Well, it sounds like it's already on YouTube.
Oh yeah, it's all good. You really never heard this song?
I don't know. I'll find out, I guess. But I don't think I've heard it.
I'm not sure this
I've
actually
heard it, but I
needed
don't
a
think I ever understood the lyrics.
I've never seen this video.
Video really adds something.
Yeah, I never visualized quite what was in his head.
Okay. Well, now I know.
Now it makes sense.
So the paper was making a joke about it, about the song being rather applicable to understanding zippers.
Yeah, it makes sense. Yes, okay.
And I hope the
Until you
visuals
talk
help.
about the rose trees, I don't think we can have trees.
We can go back and look at the rose trees now if you guys want to. We can look at the package and work through what they did.
We could go through that thing about the tape and that.
Yeah.
So I
You want me to pull up the
that's
lens
what I
code?
wanna
We can
see.
just start reading through it.
No, because that's going to be too hard. But it's tape that you can understand.
I don't understand it. How am I going to explain it to you?
All right. So how about we start with what are the types?
Of like the lens tape.
No, like what is the what's the interface look
Oh,
like?
I'll ask a question. Were you talking about like derivatives of data types and stuff? Like,
Oh,
like, is
yeah,
this
I
at all related
dropped-
to like the Berzozowski derivative?
I'm not sure.
So Berzozowski derivatives are like
Yeah.
derivatives of regular expressions in a sense, or it's
Oh, no, these are
like,
just
let's
derivatives
take
of
this.
data structures.
like, right, which is similar.
Yeah.
To,
So it turns out that when you look at the zippering operation as an operation, it acts on a traversal exactly the way a derivative does. So you pass the traversal to the derivative operator, and what comes out is a zipper. And there's a paper that talks all about that. I didn't want to get into it in this because I thought we wouldn't have
So
time.
you pass the traversal, or the traversal and the data structure, or
The traversal itself. It's a derivative on the traversal. The traverse function.
okay, so you have the traverse function, and
And-
you apply this operation to it, and you get,
A zipper.
what do you mean? What's a zipper? And what does that mean?
Exactly what we've been talking about.
No, I know, but you don't have any data yet because you just have a
Yeah, yeah,
traverse
yeah.
function. So
Right.
you get something that will turn a
You get a
structure-
one-hole context, right? So you end up
so
with
what if we do it for list?
What is the
what
type
does it happen
look
for
like?
list?
I mean, like,
the type looks exactly the way it's been looking the whole time, right? It's not a type level thing. It's just a like.
what I mean is, maybe you're not understanding what I.
I don't think I'm understanding what you're asking.
Okay, so in order to get a one-hole context, you've got to have something. You've got to have some data somewhere, and you're just talking about a traverse function, and that doesn't have any data in it.
Right, but
So what is?
so if I give you the function f of x equals x plus 1, and I ask you for its derivative, can you give me the derivative?
Absolutely.
Okay, same idea.
So it's
You still need to
something that
apply the data
if you
to it.
apply it to the data, you get a zipper thing.
You get it open. The data structure is opened up in a zipper.
Okay. Okay.
Make sense now?
And
or-
this is some kind of.
It's just a
derivative-
cool- it's just a cool
derivative
idea.
In the sense of
Well, how
taking
does it
derivatives
happen?
of the algebraic
Yeah.
data type kind of,
Right.
that's kind of crazy stuff.
Yes.
And there must be something deep reason for that, but.
I didn't get that far into it. I just thought it was a really neat concept.
Well, so could we go through it for like list?
Sure. Sounds like a good idea.
What do you want to go through? Because
How you derive a zipper, essentially, just through.
I don't understand that well enough to explain it.
Okay.
Well, we could try it, right?
You wanna try it?
So
This-
what
yeah,
is
okay.
what is
What does
a
a
list?
traversal look like then?
I mean, a list it's.
Is this
you
like
got-
the, either unit or the pair A,
Yeah.
Yeah.
right?
So if we differentiate that,
Right, this is where you get into like the, what,
So
x
this is the
equals
first
1
derivative of a
plus.
hand
Right.
yeah.